In this video, we are going to take a look at an example of how to find the critical numbers. All right, so in this case, we want to find the critical numbers of the function f of x equals x squared over 3x plus 1. This is a rational function, right, which is a polynomial divided by a polynomial. Okay, so the first step that you need to do is to find the domain of f. So in this example right here, a rational function, right, it's going to be defined everywhere except at any x that will make the bottom part equal to 0 here. Okay, so if you take the bottom part and set it equal to 0, you're going to get negative 1/3 there, right? So if you plug in a negative 1/3, right, you're going to have negative 1/3 times 3 on the bottom. That's going to give you a negative 1, and then negative 1 plus 1 will give you a 0. So don't plug in a negative 1/3, right? Otherwise, you're going to divide by 0. Every other number is going to be okay, right? So the domain of a rational function is going to be all real numbers except those that make the bottom part equal to 0 here. Okay. So the domain would be all real numbers except negative 1/3. So that's important for later on. All right, next, now that we know the domain of f, we're going to take the derivative and we're going to simplify that as much as we can. All right, so looking at this, I'm going to use the quotient rule, right? So it's going to be low, which is 3x plus 1, d high, that's going to be 2x, minus high, which is x squared, d low, right? The derivative of 3x plus 1 is 3. All that's over low squared. So that's the quotient rule to take the derivative. Then I'm going to simplify. I'm going to distribute this 2x through the parentheses here and make that look a little nicer. And then, of course, I've got some like terms here. I have 6x squareds minus 3x squareds. That's going to give me 3x squared plus 2x, right? And over 3x plus 1 squared. All right, so that's pretty good. If your function or derivative has fractions in it, you need to write it as one big fraction. So you might have to get a common denominator and combine those, or simplify a complex fraction. It needs to be in a nice format like this. Okay, just about as simple as you can get it. All right, then I am going to, what I want to know, right, is when the derivative is equal to 0, right, and when the derivative is undefined. So here, the derivative will be equal to 0 when the top part is equal to 0 and the bottom is not. So if you have your derivative and it's a big fraction like this one, what you want to do is set the top equal to 0 and solve that out. Okay, so set 3x squared plus 2x equal to 0. Then I can factor that, right? Both of these terms on the left side have an x in common, so I can remove the x, right? And now the left side is factored, so that means either x has to be 0 or 3x plus 2 has to be 0. And I would just solve each of those little equations out, and I get 0 and negative 2/3. Okay, next up, I need to check to see that those numbers are in the domain of the function f. Okay, and remember, the domain was all real numbers except for negative 1/3, right? And so neither of these are negative 1/3, so these are okay. They are both in the domain of f, and so therefore they are both critical numbers of this function f here. Okay. Next up, right, I need to know where the derivative is undefined. And so now, because our derivative is a fraction and we've got it written as a one big fraction, what we can do is figure that part out by setting the bottom part equal to 0 and solving that out. So the bottom part of our derivative was 3x plus 1 squared. We're going to set that equal to 0 and solve. So what we would do is use the square root property, right? If something squared equals this number, then that number inside there has to be either plus or minus, right, the square root of the other side. Well, the square root of 0 is just 0, and the plus or minus doesn't really make any difference here. So I get 3x plus 1 equals 0, when I solve that out, I get negative 1/3. I should have a negative right here. Negative 1/3. Okay. And we saw that negative 1/3, right, is not in the domain of f. The domain was all real numbers except negative 1/3, right? So negative 1/3 that we should have gotten here, right, is not a critical number of f. It's not in the domain, so it's not a critical number. So the conclusion is the only critical numbers of f are 0 and negative 2/3.